Hi guys, Dr. Landa here with a video on spermatogenesis and oogenesis. So we're going to look at how the difference between how sperm is made and how eggs are made. Both of them are going to go through meiosis. We have to do that to have the chromosome number, but there is a slight difference in the end result. So we'll start with spermatogenesis because it is very similar to when we talked about just generic meiosis. So we'll start with the spermatogonium. That's this cell here. That's what I've been referring to as the germ cell. So it is a 2N diploid cell. All right. It's going to have a choice. Remember, it depends on what signal lands on it, what is sent to it, what's the intention. So if a signal is sent to go through mitosis, then it will go through mitosis and it will make clones of itself. So here we've got copies, right? Good. Perfect, exact copies. They look exactly like the parent cell. And these are both 2N. Why do we need to do that? Well, think about it. If we had a certain amount of germ cells and we were always pushing them into meiosis, eventually we would run out of that bank of germ cells, right? Well, in particular, men produce sperm throughout their lives, so we know that that doesn't happen. So the solution to the problem was to keep the bank going, and to keep the bank of germ cells going, some of them must go through mitosis relatively often. All right, so if they do get the signal to go through meiosis, okay, we will call that cell that's going through meiosis the primary spermatocyte. So a primary spermatocyte is a 2N cell. It is diploid. Okay. It'll go through meiosis 1 and it will become a secondary spermatocyte. Now take a look at this cell and think to yourself, how does this chromosome number compare to this one? Well, there's half as many, so this is haploid, and it is the N number of chromosomes. For this little picture here, we went from 4 to 2. Okay, then we go through meiosis 2. I'm going to abbreviate it M2 just because I don't have a lot of space here. So meiosis 2, and in meiosis 2, the sister chromatids are separated, and we end up with 4 unique daughter cells. They are unique. Okay, we will call these guys, the ones that are just finished meiosis 2, we call them spermatids. Okay, sorry about that. Spermatids. Okay, those will eventually, they will mature. They are not ready to go out and do their job yet. They have to mature. They have to lose some cytoplasm. They have to get this cap here. They got to get a tail. So they will go through a maturation process in the testes, and they will mature, and eventually they will be sperm. And notice that again with crossing over and with independent assortment, that all of these sperm will be unique. Their genetic combination is unique. All right, now we'll look at oogenesis, which is production of the egg or ova. All right, so here we are in the ovaries. This is the germ cell, and it's called the oogonium. Okay, and it is diploid. 2N. Okay. In the ovaries, these cells can go through mitosis to make more oogonium, or to make a primary oocyte. Okay, so I just have to mention that this is kind of unique. We talked about spermatogenesis happening throughout a man's life. As soon as puberty starts, sperm production starts, and it looks just like that picture I talked about. Now, oogenesis is different. Oogenesis actually begins in the fetal stage. So this is occurring in a female fetus, this process. And it will stop, this is meiosis 1. It will stop in prophase 1 of meiosis 1. So I'm going to draw like a little dotted line there. During development, during fetal development, there will be a pause. Okay, so we've got some primary oocytes created and they have entered into meiosis, but they pause at prophase 1, during prophase 1. Okay. Then every month, one of these primary oocytes will be chosen, for lack of a better word, and this is every month after puberty begins for a girl, and one of those primary oocytes will be allowed to go through meiosis and possibly become the egg. Okay, so here's how it happens. The primary oocyte is going to go through meiosis, and one thing this picture doesn't do a great job of doing is showing how the cytoplasm really separates, at least at this first step here. So the first division creates what's known as a polar body. Okay, and a secondary oocyte. So there's our polar body and secondary oocyte. In this picture, honestly, they look exactly the same except for the different chromosomes that ended up in them. But in fact, the polar body should be smaller. And notice all along the way, at the end here, you don't see 4 eggs, do you, like you saw for sperm. You're only seeing 1 egg at the very end. The whole goal of oogenesis is to have 1 big egg, right, that has all the cytoplasm, the cell machinery, nutrients, it's got all the mitochondria, it's got all the good stuff. And the other ones, these other small things, which we're going to call polar bodies, are kind of like garbage cans. We have to go through meiosis to have the right number of chromosomes. So we have to do this process, but we don't want to use those other chromosomes. So this is just like, polar bodies are like garbage cans for extra chromosomes. All right, so this is the first polar body here that comes out of meiosis 1. And this first polar body is likely to disintegrate and just go away, but it's possible that, that it could go through meiosis 2. If it does, it really doesn't matter. It's not going to be the one that's fertilized anyway. Okay. That back there. Okay. This is the guy we're really interested in here. This secondary oocyte is going to be what is actually ovulated. The secondary oocyte is when we say that a woman ovulates an egg every month, in fact, it's really a secondary oocyte. So this is what is ovulated. And that's what's going to go down the fallopian tubes and possibly be fertilized. If it's not fertilized, it will stay a secondary oocyte and it'll be shed along with a monthly period. If it is fertilized, let's draw a little sperm in here. Here he comes. Okay. If it is fertilized, then meiosis II will complete. So the sister chromatids will be separated, as you can see there. The sister chromatids will be separated, and one of the daughter cells that comes out of this cytoplasmic division will be big. The other one will be a little garbage can of extra chromosomes, and it will most likely stay attached to the egg, just sitting over there on the side. Some people say it's adnexal. It's stuck to it, not a part of it. It does go through cytokinesis. Eventually, will likely dissolve. Okay, so if fertilization occurs, meiosis II will complete. The sister chromatids will separate, and one of those daughter cells will get all of the cytoplasm and the sperm. Okay, and it will become the fertilized egg, and that will be the zygote. All right, so that's different than sperm production. In the end, we do end up with a cell that is haploid. Okay, actually, all of these three polar bodies are haploid, but only one of them gets all the cytoplasm, and that gets to be the egg, or the better word, ova. Okay, or ovum, ova plural, ovum singular. Boy, those look like both V's. Oop. There you go, ovum singular. All right, if you have any questions on spermatogenesis or oogenesis, feel free to contact me.